So we're here to solve this TomTom Skyscrapers hybrid by Serkan. It has a lot of tetromino shapes in the grid, as called out by the theme. And as I'm looking at it, the TomTom clues are going to be valuable eventually, but there are so many outside skyscrapers clues, we should start with them. We've got a 6 right off of this one. Looking from the left, there's got to be a 6 in one of these cells that are 4 or more away from the side, but the 3 up above is going to eliminate choices. That means there's going to be a 6 in one of these cells to evaluate the above clues. The 6's can't be right next to these cells with the 2's, so there are also 6's in these middle positions. We've got some 6's in this lower left space, 6's in that top left space. So all the 6's are now into the grid, at least as notation. We can do our usual step of thinking of the next largest the 5 would be the value that's one below 6, but still hard to place into the grid. And a clue like this 4 skyscrapers clue is going to be a key one, because you can't have a 4 or a 5 right next to it, and even one cell away you can't have a 5 in the cell that's currently the highlight square in red, because you'd see this first building, you'd see a 5, and then you'd see the 6, and you'd see 3 total, and you'd see 4 here. But there's some places, if you don't know this is a standard skyscraper rule, cells like this or this or this, which are 1 away from a 2 on an edge, are also cells that can't have a digit like a 5 come through with them. If this is a 5, then whatever value is here, it sees this building and then also sees a 6 up above, and that's not going to work out. And so with that not being able to be a 5, we're in a situation like this. And that still looks like there are too many choices, but we now have the TomTom rule come in for the first time. If this is a 5, 6 minus 5 is what this will have to be. That's already 1, and I have to subtract 2 more numbers from it. I'm going to get to a negative value. And I think one of the ways to start this grid is to see that this 5 is fairly constrained in the second row. And just for kicks, I'm going to look at this other most constrained set of rows, which is this 3 with a 1 on the right. And I'm going to look there in part because I see another example. 6 minus 5 is 1, but minus 2 more digits, I'm not going to get to 0. So I'm going to have to place a 5 on the left side. We talked about why this doesn't work. And this is the kind of cell we mentioned before. This is 1 away from a 2, so this also can't work. So 5 is exactly there in that spot, and that's probably going to give us a lot of potential headway. What it does is now puts in the 0 cage, a place where the 6 really can't go. 6 minus 5 would cause problems straight away. So the 5 is here. Notice that another 5 can't be in this cage, so a 5 is in this spot, and 5 in 2 cells, that's a 1 with a 6 up above. The only thing left is 5 minus 4. So we get this into the grid, so it's pretty good. The 5 still down here, I'm looking at the extreme values. If 2 and 3 are used and the 1 is up above, then 5 minus 2 minus 3 is 0, but we have 1 more cell to go. And so I think I can eliminate the 1 up above. So for sure, a 1 is in one of these 2 cells. And that might help us as we think over to the right of the grid. But the options will be 1 and 2. 5 minus 1 minus 2 would leave behind a 2 here, and 5 minus 1 minus 3 would leave a 1 here. So I think we can mark effectively that this cell is 1, 2, and we're going to have 2 options. That will give why that's the case. We have to still consider things like this 16 and this 14, and I think the thing to note is that the value in the bottommost cell is going to be larger than the value one above, and that probably means that this has to be a pretty large value up here, like 4 or 5. Let's take a case like if this were 2, this cell has to be 1. That's going to not give any value for the sum to the right. If this was 3 instead, then the largest could be is 2. 6 and 3 and 2 is 11, which needs to take a 5. If this were instead of 1, this would need to take a 6. That's no good. So this is 4, 5. And the value in this cell is going to be 1 less, but there's not really too much information yet that we can do about that. Notice, though, that with this being 4, 5, we probably have some constraints on this over to the right, this 6. Like, where will the other large value go? Like, a 5 doesn't go in either of these cells. So if this is not a 5, if this is instead the 4, the 5 is over here. So let's see if we could place a 4 into one of these cells. If a 4 is in those cells, the only way it can go is, I think, looking like this, but these 1s are going to point over to the ones to the left and cause problems. So I think we actually have the identification of a 4-5 pair based on needing a large value to get the 16 to work and small values in these cells that are near the 0 to get this to work. And that's going to give us probably some reasonable headway on the right side, and that's because a column like this can no longer now have a 5 in the cell because it would need a 5 of a 4, and that's already down below. So for sure, the 5 isn't here, and we said before why a 5 can't be in this TomTom cage with a 1 value. So the only place a 5 can be is here, and that actually eliminates this. We now have where this is a 1, 2, 3, and we've got a sum of 10. So if this were the 1, there'd be a 5 to the right. That's no good. If this were a 2, there can be a 4. That looks okay. And if this were a 3, there'd be another 3. That's not good. So this is 2, 4. We've got this. 6 minus 1 would be minus 2 and 3. 6 minus 3 would be minus 1 and 2. So there's always a 2 in that 0 cage to get 6, subtracting 1 and 2 and 3. So this is 5 minus 1 minus 3 minus another 1. So I think we've conclusively set this value. What more do we have? We have to place a 5 in this third column, and it's got to be near one of the 2's. It can't be anywhere else or it'll be seen by one of these 2's. So it's up at top. We now actually have 2 5's left to go, which are in those cells. But it can't be up here because this will make this cage invalid. So I guess a 5 dodging this cage has been used now 3 times in the puzzle. And we look like we're here. This is a 2 of a 3. Let's think about, I think there's a space where 2 right here is going to mean we don't see enough buildings. So we need to see a taller building here because there's a smaller building that's going to follow. So this outside clue looks fine with this breakdown. We have 2, 3, 4 potentially in these cells. We can think about how to make this 1 work out, and it could be a subtraction or division. There's still a fair number of choices for it. We have a 1, 2, 3 here. Trying to see what a constraint is that's important. I think one thing is that this cell can't be a 4. 6 minus 4 needs to take 1 more away, but 2 cells, and it's not a division, so this is 1, 2, 3. So it looks like the constraint is that in this 5th column, the 4 is up at the top. And we now have to figure out where can we place last 4's. So there's going to be a 4 in one of these 2 cells, a 4 in one of these 2 cells. And in thinking through this, all the outside clues look like they're satisfied, so I'm not concerned with the outside clues right now. Just confirming that's right. Yeah, all the outside clues are satisfied. So this is all at the level of the TomTom. So let's see what would be the most breaking of a set of things to do with the TomTom side. The big values down below feel better than having too many values up above. So I think one thing that's breaking from the TomTom side is having a 1 here, which would make this need to be a 2 and have a 3, 4 up above. So this is a 2, 3 at most, and so the 1 is up top. We want this to be subtraction or division, and so if this is actually a 4, that looks like that is what's breaking things. 6 minus 4 is 2. It's not going to work, so the thing we can do for sure is actually place a 4 there. Sorry, it's taking me a little bit of time to see that, but this is the natural headway. We have 1, 2, 1, 2. We have a few ways this can then work out as a product, but I'm just going to come back to the middle of the grid where I've got some fixed things that I can put in. And cancel these out. The last 2 is here. There's a 2 here, which makes a 3, puts a 1, puts a 3, puts a 1, and a 3, and a 1, and a 3, and a 1, and a 3. Got a chase of this 2 over here, a 2 of a 1. and this last cage would have been a division. 6 divided by 2 divided by 3 divided by 1 is 1. So all the TomTom constraints are satisfied, skyscraper states are satisfied, and we finished out this tough puzzle. It did require shifting between modes of thinking. It really started from placing these big 6s, but then thinking through with this 5 and this 5, why they were dodging cells like this, and also dodging cages like this. With the 5 placed, we had to put a big cell, the 6 further away, got some big cells here. That would make it possible to fill in this cage. That gave us where the 5 went in this corner box. And I think then the thing I didn't track quickly was a 4 can also be up top. So we get a 5 has to be here, a 4 has to be here. And so this 4-3 placement, basically all these cells together, should be the natural last constraint of the puzzle. It just took me a minute and a half or something like that to get, after placing the 5, to seeing where the 4 goes. So hope you got a little bit out of this solve and a little bit of a sense of how through PenPy Edit you can play through skyscraper puzzles and marks of notation, shapes, and cells. We'll see you again soon.